Okay, AP Calculus AB. Change a variable with a log rule. Here we're asked to find the indefinite integral of 2x over the quantity x plus 1 squared dx. And as I look at this, this is not the easiest one in the world to figure out how I was going to tackle. So what I decided was I looked at the bottom and I was like, is it possible that this piece at the top is a derivative of the bottom? And I actually had to FOIL this out in my head and come out and I realized this is part of that derivative. So this is the way I started to go about this. I used u substitution and I let u equal x plus 1, which would mean that du dx, the derivative of this thing, would just equal 1. And if I solve for dx, I'd get that dx is equal to du. And I was like, okay, I'm not sure how that helps me. So I started to look at that. And this is where I started to substitute stuff out. I'm like, I got 2x here over u squared du. But as I looked at it, it didn't help me. It didn't get rid of any of this crap in here. So I started to try to figure out, okay, I'm stuck here. I have everything in terms of u except for this piece. And when I did the derivative, I didn't get anything that canceled. So what I decided to do is I took this piece up here, and I solved it for x. And I got x is equal to u minus 1. So then I was like, okay, I'll sub this in, and I get this is 2 minus 1. Now I have the whole thing in terms of u, which is better for me. What I did in this case, I went ahead and distributed this in, and if it's not the way you did it, you can do it either way you want, but I went ahead and distributed it in, and I got 2u minus 2 over u squared du. Now I'm looking at this thing now, and I have these two terms up here, but I only have a single term at the bottom, which makes me think I should partition this thing out. So I started to do this. I partitioned this thing out. I'm like, okay, I got 2u over u squared, right, du, minus, and I'll show you in a second, but I'm going to pull this 2 out, minus 2, and it's u to the negative 2, right, this thing, du. And if you're wondering why I didn't do it on this side, because here I think I'm going to get an ln out of this. What I probably will do is I'll pull this 2 out here, though. I'll pull this 2 out to here. I think that's okay. I'm just going to keep working here. As this thing goes through, u over u squared is 1 over u, isn't it? So you can see that. Now I have du over u, which is an ln, isn't it? So as I start to integrate, I'm going to go ahead and integrate now. As I start to integrate, I'm starting to see this thing evolving. And I know that anytime I have the derivative over the function, I have an ln. So I have 2 ln of absolute u minus 2. I'm going to differentiate this, right? Which will give me u to the negative 1. I'm adding 1, right? And whatever I get here, I get at the bottom also. I get negative 1 here. So this thing, negative and a negative is a positive. So I hope that makes perfect sense to you, right? And also, hopefully you can see that u to the negative 1 is the same as 1 over u. So I'll take this and put this whole thing over u plus c. And I'm actually pretty much done, but I have to resubstitute. Remember that I let u take on a value. So I'm just going to go ahead and resubstitute. Now I'm going to get 2 ln of absolute x plus 1 plus 2 over x plus 1 plus c, remember, because this is a indefinite integral. So that's my function that I got back. And if you want to know if this is right or wrong, then what you could do is check this thing by differentiation. All right, you guys, I hope this was really helpful. You know, the more you see of these things, the more you practice, the more individual examples you see, the more palatable this becomes. So it's kind of a pain in the neck right now, but hang in there. I promise you're going to be able to do this really well, all right? Hang in there. If you haven't already subscribed, please subscribe, and your comments are always welcome. Thanks very much.